Welcome back. In this lecture, we'll examine another aspect of manipulating data, stripping values. We'll explain what stripping is, why it's important, and how to execute it with NumPy arrays. As always, we start by loading and displaying the dataset we want to use for this lecture. For this specific lecture, we want to use only the text data from lending company total price. If we quickly open it in a simple word editor like Notepad++, we'll see that we store such data in columns 2, 3, and 5. So, to import it in Python, we need to set the correct delimiter. Choose NumPy string as a data type, skip the header, and only take the second, third, and fifth columns, which have indices 1, 2, and 4, respectively. This looks oddly specific. However, to understand how the strip function operates, we only want the columns which contain non-numeric data, as we can't strip numbers. All right. We see an array with 3 columns filled with text values. The common theme is that in each column, there's a piece of string that appears in every single row. For the first one, it's ID underscore. For the second one, it's product. And for the last one, location. This is crucial because we'll be stripping each column of these excess strings. So, stripping in data manipulation refers to the act of removing specific parts of strings. We're not straight up deleting the values stored in specific positions, but rather taking away small parts. That's useful because it allows us to get rid of excess data and transform text values into numeric ones to analyze them quantitatively. In NumPy, we use the strip function from the character array module, abbreviated as char array. To see it in practice, let's remove the ID part of each entry in the first column. We start off by calling the function and adding the first column of the text array as an argument. Next, we put a comma and, in quotation marks, indicate the text we wish to remove from every value. In this case, we want to delete ID underscore. So that is what we write. The output is a flattened array of numeric values with quotation marks around them. Hence, we've successfully removed ID underscore from every row of the column. Like many other functions we've examined so far, strip doesn't modify the contents of the object it has been applied to. Thus, we need to store these values over the current first column of the dataset. Now that we've seen how to strip elements from an array, we can replicate this code and remove product and location from the other 2 columns. Simply copy the code we just wrote twice. Change the indexes from 0 to 1 and 2, and switch out ID underscore for product, empty space, and location, empty space, respectively. We see an array which no longer contains the excess strings from the start of the lecture, which was our goal here. See? Of course, stripping the text values from our initial array is part of what we could do to preprocess the data. In this example, we can also apply np_where to transform the letters in the second column into numeric values. By changing A to 1, B to 2, and so on, we're transforming the entire array into numeric values. This is the format we need so that we can manipulate our data while doing quantitative analysis later on. However, there's one more step to make before we get to that point. Quotation marks around numeric values means these are strings that only look like numbers. Hence, we'd need to use the assign type method to cast them as integers and overwrite the initial array. Once we've done so, we've managed to completely transform an array of text into a clean array of numeric values. Great job! Now that you've seen how some of these methods and functions work together, we're ready to move on to shifting data around by stacking it. In the next lecture, we'll learn stacking and how it works for NumPy arrays. Thanks for watching!